All right, so I'm Jonathan Alexander with Albermarle, and I lead our data analytics efforts for manufacturing inside our global operational excellence group. And so I'm going to take you on a journey on kind of my personal story and how I used data analytics just to solve some of the problems we were dealing with inside manufacturing, and then now how we're scaling it with this global project AI, which in Albermarle we call that Albermarle Intelligence. So we'll start with this. This is an example from one of our sites where a process supervisor gets to the plant at 5 a.m., has to wake up probably at 3 a.m. to do so. At 5 a.m., he spends 2 hours going through a series of trends and data trying to figure out how the plant did in the last 24 hours. And so what he's looking at here is on the left side, you'll see process data. These are what we call trends, things like pressures, temperatures, flows. And on the right side, we have analytical data. So this is coming from the lab, measuring percent aluminum, particle size, those types of things. And this process supervisor for 2 hours is trying to figure out, over the last 24 hours, our process ran like this, and we got this result, and what went wrong, and what do I need to do about it? So he would start with a trend like this, and it's a batch process, and he might look at this and say, what nuances do I see? What things different happen between the batches? And he's got this notepad, he's writing it down. So here you might see, I got this green bar that might be wider than the other green bars. The yellow squiggly might be more squiggly than the others. And he's writing all these notes down. But it's not just this process, it's this process. And also this one. And he's going through a series of these charts and trends and units, trying to notice all the key nuances in the data. And he's jotting all these down at 5 in the morning. And then he's got to go and communicate that with his team. And so what we did at Albermarle is that was kind of the initial part, is how do we stop this? And how do we notice these things before they happen? And so what we did is kind of did this data analytics control room style. So it's Pac-Man statistics. We took something complicated and all this data and we try to simplify it. It's either Pac-Man or not Pac-Man. It's either good or bad. It's right or wrong. It's green or red. And so that led us into a first series of these dashboards where we use statistical process control to monitor all this data and give us alarms when things would go out of range. And very quickly, within the first 6 months of doing this, we saw lots of results. This is final product, intermediate quality, final product. And I could show you hours of these different trends. Very quickly, 18 straight months with zero out of spec product. First time ever, $650,000 in savings. Went to a completely different business unit, different plant, different people, different chemistry, $1 million risk mitigation. And we have these all over. I could spend all day going through results. But very quickly we said, what's next, right? So we're all going on this machine learning piece. So we did a year and a half ago a machine learning trial on this vacuum pump train. So we took 32 variables across 2 years of data. And this is a pretty robust vacuum pump system. It's got 3 vacuum pumps in series, pulls super deep vacuum. And we ran this model. And the algorithm's called principal component analysis. And this is a 3-dimensional depiction of those 32 variables over 2 years. And I won't go into the details of it, but basically this is a cluster analysis. And so you have 2 different kind of clusters and groups kind of circling around. And we looked at one of those clusters and found, well, that's when the vacuum pumps are down. So we're like, great. So we delete that data, rerun the algorithm, and when the pumps are running, we found 3 unique modes of operation, 3 unique clusters. And so when you present this on a different scale, this brown chart that you see, this is 2 years. The brown is kind of the model, the health of the model. And that first center cluster is all this data. And then one cluster is this data, and the cluster on the right is this data. And we pulled failure information on these pumps. And we found we had a motor failure here, and we had a seal failure here. So when you zoom up on this, we have a guy, a maintenance technician that goes around every 30 days, and he puts a vibration meter on these pumps, to measure vibration. And on July 30th, no vibration. August 30th, high vibration. Well, the model found it the moment it happened and actually told us that the seal pot level went empty, causing the pump to cavitate, and we ran like that basically until the whole pump system failed. So the problem with these is that a lot of these machine learning models and these tools that you're going to show engineers present data kind of like this. Lots of great graphics if you're an engineer or a data scientist or in research and R&D, but in manufacturing, are you going to be able to show these to your operators? Something like this, a neural net, how are they going to respond? So our approach to this was to present it back like this, that Pac-Man style. It's either good or bad, it's right or wrong, and you're either going to do something with it or not, right? It's just a simple green or red. And so they click on this, and our machine learning model presents it back just like a SPC chart, but it's a little bit more sophisticated. So each data variable is a summary of 32 variables. And it goes out of control, operator clicks on it, and it gives them a contribution of which variables are causing the variation. And then they can go and further drill down. So this is kind of the motto that we live by Mr. William Deming, and I love this quote. But we were really kind of proud of ourselves with this whole data analytics initiatives and the results that we brought. And so that brings up this Project AI, this global thing that we're trying to scale. But there's some things that your data won't tell you. So I'll give you a personal story of this one time I was trying to tune a control valve, as part of our improvement process, and adjusting the proportional gain, the integral gain, not responding like I'd expected. So I go out into the field, and this control valve, has a positioner where it receives the electrical signal, and it has this linkage arm that links to a mechanical valve. And I found out in the unit, this linkage arm had a bungee cord tied around it to the nearby post. So apparently an operator had seen the same variation, the same swinging, and they didn't have the knobs to turn for proportional and integral gain, so they had a bungee cord. They went to their shop, they went to their storeroom, and they saw, okay, I got duct tape, I got channel locks, WD-40, I got bungee cords. What solves my problem? These are the tools they gave me. And they grab the thing that makes sense to them. That's how we're preparing our people for digital transformation. So when you're trying to think about, where do you apply these tools and where do you merge it with people, you kind of can think about it in this way. This is the skills, rules, knowledge, expertise chart, and it's really based on level of uncertainty with your data. And so as uncertainty increases, you need more people. As the rules get are more simple, you need less people involved. And right now, we already have tons of automation since the 80s of, you need to turn this valve on, turn it on. You want to set this timer. But if you want to do, hey, I'm not running like I have in the last 10 years, why? It gets to be a little complicated. So I'll give you a personal story. This is my Roomba at home. His name is Roger. And Roger every morning gives me a notification at 5 a.m. that he's stuck on a cliff. And so I go downstairs and I see Roger here on our rug underneath the table. And what you don't know about Roger is he has 6 sensors underneath the bottom of this Roomba. And the sensors are cliff sensors. But the way they're designed is to detect light. And so if they see something very dark, it assumes that's a cliff and an edge, and so it kind of shuts down. Well, it wasn't designed with the intention of this rug with this super dark, black streaks in it, and so it finds its way on this red piece and gets stuck, and every morning I come down and I find it at a new spot on the rug, and every morning, Roger, I got to bring him back to his docking station to get him started for the next day. And sometimes underneath the couch he gets stuck. And I'll even give an unpersonal example from the internet. You might have heard about it. But there's an unfortunate dad who also has a Roger, or Roomba, I'm not sure what he calls, and he also has a dog. Maybe the dog's name is Roger. And the dog left a mess one evening, and the Roomba went ahead and did its normal task and proceeded to move it around the house. Unfortunately, the guy had to replace all of his carpet, and the Roomba company was really nice. They sent him a free Roomba to replace his broken one, so I guess that made up for it. But when you're thinking about your chemical plant, are you ready for Roger to take control of your plant? And I think that's why we're all here. It's like, where does it start and end? And so our approach at Albermarle was, you got all this data and we give you a couple alarms, right? Of like, hey, statistically, these are outside of the norm. And with machine learning, you summarize large amounts of data streams You put them through all these different models, right? And then you can say, okay, well, this is running good and this one is running bad, but then our plants are a lot bigger than that. So we have these data streams and all of these. And so we just say more machine learning models, right? We just continue to add them up, summarize all this data, and then present it back into this, simple. From a data analytics perspective, I'm done. They have all the tools that they need. Well, there's some things that we forgot about this. This is our solution to this, is that you take all this information and you can't automate all of this at the beginning, right? Because sometimes you don't know if there's a bungee cord around this data stream, right? So we say, okay, we'll analyze it, give it to the operator, give them an alarm, and let them kind of make a decision. Well, I'll give you another personal example. When I started on this road, and a few years ago, I did a presentation. This was in my presentation about how great these tools were. I was so gung-ho about it. And this is my own home personal dashboard. I monitor, okay, when do I need to rotate my tires? When do I need to change my air filters? Things like that. And so you can see my garage needed some work at the moment. And over time, I pulled it up recently, and this is what it is now. And so there'd be moments where I'd be on vacation and I'd get an alarm, got to change your air filter. What do? Well, ignore it, right? Or watching Netflix and they're like, okay, the next show is starting and I get an alarm, got to rotate my tires. I'm like, I'll do that tomorrow, right? And then 3 years later, you get this. But we're pretty comfortable in a chemical environment, manufacturing, doing this to our operations staff. And they have a way of solving it, right? I've even seen in a processing unit, I've seen an alarm that was measuring water pressure, header pressure. And this alarm was intended to, whenever we pulled a safety shower, right, the pressure would drop, you get an alarm, and it would flash and have an audible signal. Well, it also would flash whenever someone flushed the toilet. So what happens, they cover it in duct tape, and it loses its effectiveness. So what we're trying to do here is we've, as an industry, kind of centered around this upper approach, this upper trend where we give them lots of alarms in the DCS system and now maybe with this analytics system, but they don't have much to do with it. They don't have the right tools to respond. So our goal is to get down to where when we give them an alarm on these systems that, hey, they got to be able to do something with it. And it's not just always the operators. Sometimes it's also the engineers. And recently, this data is actually very new. This is from November of 2019. We had engineers, analyze some data based on history and said, okay, based on this data, we need to run here. And I'm going to put up some specifications. If we run outside of here, I want it to alarm. Well, guess what? Process shifts, you change the equipment, something happens. Well, the engineers stop monitoring it, but the operators still have to acknowledge it. And over time, it makes it less and less useful. So one of the things that we're doing, and from a global approach, is one small way we're trying to handle this, set up some metrics around this, being able to measure the amount of analytics we're doing around machine learning and measure the responses, right? And being able to understand, hey, is it A shift's problem or C shift's problem? Is it this plant's or this plant's? Are they acknowledging the alarms? Are they not taking action on them? Or on the top right, you see number of alarms with preventative actions. So is the engineer coming back and following through with these things? So this is one of the areas we're looking at. And one of the big things that we've missed on all these other little pilots is change management. And from a technical perspective and my engineering background, it's, hey, what we've done before is we give them a tool, we train a couple champions, wipe our hands clean, we're done, move on to the next initiative, right? That's probably how many of you have done this. So what we're doing is we're using this company called ProSci, and they have this ADKAR model, awareness, desire, knowledge, action, reinforcement. And we have things and processes we're going to address each of those things. And I could spend a whole hour just talking about this approach, but we're taking this from a global, getting everybody involved. And when you think about, okay, you've seen this 3 keys to digital transformation, right? People, process, technology. You take your data, you put it in the whole system, it cranks out tons of cash, and that's really great. But what happens when your people stop working, right? They kind of put the rest of the system in a bind, and that's where you start to lose your ROI. So I'll end with a series of kind of personal stories. on our people. So this is Sean Curry. He's one of our operators, outside operator in our DF1 unit. And every morning with our engineers, operators, unit leaders, we get together and we go over these dashboards and discuss, what happened over the last 24 hours, what nuances in the data did you see, what actions did we take, and we came across this chart. And this is another control valve, and if you look at the scale, it's kind of small to see, but it's 8.002, 8.004, very tight scale. And so everybody in the room kind of said, oh, well, I don't care about it. It's too tight of a scale, doesn't matter. Well, statistics says it does matter. It doesn't care where the decimal point is, okay? But when we were asking about what happened at this moment when it started swinging, Sean spoke up and said, well, I think I know what it is. And so he took us out into the field, and on the left side, you can see the red control valve. That's the one we're measuring. And on the right side, on the uphill pipeline, you see this manual block valve. So what he said, there's this operator on A shift where he sees this valve chattering, and so what he does, he pinches back on that valve, and it reduces the chatter. Same with the bungee cord, right? There's a trend here. And we found that had a huge impact downstream that no one in the room knew. And we had a process supervisor that had been in that unit for 30 years, never knew people were doing this. So that's the value of getting people, your people, involved in these discussions. This is Daniel Chavez, one of our board operators, and we encourage our operators when they see these alarms to, get the team involved. If you don't understand what's going on, shoot us an email, explain what you looked at, or if you just have ideas, keep us posted. So he wrote one long email, and he writes lots of these, to our whole team and kind of explain what's going on, but at the bottom, I'll read it for you. He said, I could not fit this into the cause and action section of NWA. This prompted to send an email. I hope this might be helpful or that it makes sense, for the night is long, I grow weary, and the machine still beckons. So he wrote a meme for him to play around the control room. But this is the value of getting your people involved and having them be a part of the team. This is Michaela Bilski, one of the newest operations engineers we have in the company. And she's very fresh out of school. And typically, in my experience, and probably many people in your manufacturing facilities, the operations engineers get thrown into the fire and they're just trying to survive. And they're trying to just keep their head above water. That first 6 months of running the unit kind of tanks a little bit on productivity maybe. And then after they get their feet up under them, they're just maintaining status quo. Well, because of these systems, we were able to have the unit and the operators and the shift people maintain the status quo. And then these new engineers that are coming in actually get to understand what the unit's doing, not have to respond to the day-to-day fires. And she, in the past year, has already done 10 to 15 improvement projects on these units. And that's the scale effect. That's compounding interest. And that's what we've missed out. This is David Sullivan, another board operator, been in the unit for 30 years. So you probably can imagine his enthusiasm with our digital transformation efforts. He was the first person to jump on board with new technology. And, we heard an earful from him, but he was very important, understanding the process. And we say, hey, we want to change this, knob from 2 to 8 to do an improvement. And he would say, well, I did that 15 years ago, and this was the effect. Or when we're looking at something, what data should we be worried about? What matters to you? He was the person that helped us get the history and paint the picture of the process so that we could use these technical tools to feed into it. And I'll end with this. This is Keith Bailey, and he is the process supervisor from the beginning, the one that gets to work at 5 a.m. and pulls up these trends. And while Keith has over 20 years of experience, very technical, very great understanding the unit, and he was really great on the people side. And that's one thing that we missed in some other units. And people like Keith are the ones that kind of keep the morale building in the whole unit. And so he was the one that could he understood the vision, and he put the whole picture together for people. And one example that he said is we had this operator we were trying to get involved more. And so he noticed that one day the operator was in the kitchen making some breakfast, cooking some eggs, and the board PC, the board operator, called him on the radio and said, hey, the the tank level's full. I need you to go take a sample. And so the operator's like, oh, I just made my eggs. And so he ended up having to go take the sample, came back, ate some cold eggs. So Keith had said to the operator when he was talking about this, well, if you were looking at the data, you'd have noticed that it was trending up on this level. And if you were into the system and engaged in the team, you could have waited to cook your eggs. And so now you can happily eat your eggs warm right after you make them. So it's little things like this, that really add a lot of value to the whole picture. And I could spend, I have stories about tons of different people. I could spend hours talking about it. But I really want you to think about how these tools enable your people. And when we talk about Albemarle at powering potential, right, the real value we've seen in the company is the people, right? And how are these people enabled? What tools are we giving them? And then really how are we analyzing their value and really getting everything that we can out of it? And so that's where we found the opportunity. So that's it for me. Thank you, guys. Sure. Yeah?
Sorry. My question for you is really, what did it take to change the culture? And did you have a culture where you believed you could upscale the operators, like that leadership, that the plant leaders and all that could upskill the operators? Because that's one of the challenges I seem to face is there's kind of culture of these people aren't going to get any better. They don't care, blah, blah, blah.
Yeah, so we're still, like I said, we're still struggling with that, right? And so that's this. So I really, you should look up ProSci, PROSCI. It's a company for change management. And we had a few people in our company go through this program. But we're going through this process, and they have lots of tools and techniques to be able to take you along that. And if you think about it, one of the things is they talk about is creating desire. What's in it for me, right? And so you have to think about who are the people that are going to be involved in this, and be able to present that and say, this is the value. You don't have to eat your eggs cold anymore. Things like that are some of the things that we found. Now, when I started doing this, I sat behind the scenes. I did it on my own plant because I needed to, figure out the day-to-day problems. And so I knew the process. I wrote all these analytics. I pushed out the alarms, and I kind of wiped my hands clean. And then I started noticing everybody started fighting it. Nobody was, following through. People weren't taking action. It was like, what's the deal? And it was because I didn't get them involved in the process. So some things we've done is set up meetings before we do these things, and we've talked with every single person on the shift, management leaders, operators, and we say, what do you want to look at? And they start to build this system out. And then we go and put it back into the system. And then there's this whole teamwork of feeding back and routine meetings and those types of things. And then one of the other things that we're looking at from a global perspective is, sponsorship. You got to have executive and sponsorship on all levels. And so, but the ProSci thing, I would encourage you to look at that.